thanks for leader association, so we can meet here together and exchange our ideas about energy storage and the renewable energy market. Here, I would like to bring one case to study about when about PV plus energy storage and a diesel generator solution in Maldives countries. And my name is Frank, okay, General Manager of the TrinaBESS, one company of the Trina Solar. So who is the Trina Solar? Most of the here now the Trina Solar name. Here I would like to take you a few minutes. I still repeat the Trina Solar developer role. Trina Solar founded in 1997, one of the earliest Chinese solar companies IPO in New York Stock. Till the August this year, Trina Solar accumulated shipment reached 30 gigawatt, listed #1 in the world. Till today, more than 20 production and sales center around the world within 40,200 staffs globally. Trina's headquarters in China, not so far away from Shanghai, only 1 hour rivers. Here is list you some key milestone for Trina Solar development. 1997, Mr. Gao was the chairman and the founder in Trina in China. 2006, to be the list in the New York Stock. But now, this March, we quit from New York Stock, and now is in the process to be the China IPO market. Should be the list in the China IPO market in the middle of the next year. In 2014, Trina Solar module production and shipment record world #1 in the world. In 2015, CEO Mr. Gao was elected to be the co-chairman of the Global Solar Council. Last year, IHS point out that Trina is the world's most bankable PV module manufacturer. And let's go to the TrinaBESS. TrinaBESS means battery energy storage system. In 2010, Trina Solar has a small team to trace energy storage technology. At that time, it's not a business unit, it's just a small group, small team. And until 2015, May, first 100 megawatt pack production line and 200 megawatt assembly line into the operation. In the end of the 2015, TrinaBESS became the independent company of the Trina Solar. Till the last April, TrinaBESS, there is more than 100 R&D staff with rich battery technology and the system experience. In last August, TrinaBESS shipped the first energy storage product to the Japan market. And until now, more than 1,000 residential product, energy storage product to the Japan market. And in this February, first residential ESS product to Germany market. According to our accumulation, TrinaBESS takes the residential market around 3 to 5% global market share in this year. According to our planning, TrinaBESS battery cell factory into operation by the end of the next year. Of course, TrinaBESS target top 5 battery energy storage solution provider by the 2020. TrinaBESS provide not only the product. Another key for TrinaBESS is to provide turnkey solution. This is what we discussed today. Show you one case. At the moment, Trina Solar has changed their strategy from the PV panel manufacturer into one smart renewable energy provider. So this is Trina Solar, the strategy change at this moment. So that's the reason why Trina Solar extended their business from PV system, PV panel, to energy storage system. Even the smart energy energy system. TrinaBESS, provide integrated solution, to customers. That means we provide requirement analyze, solution design, components survey, and system integration. If necessary, Trina Solar and the TrinaBESS can provide finance support to the project and the customers. Now, TrinaBESS is set up one founder with $1 billion to support energy storage project. Of course, we have several key figures have to meet if we need a finance, bridging finance. Here, it's one case I will show everybody. Microgrid project. Before we show this case, of course, microgrid have a lot of the advantages. Here, I don't repeat again, because this morning, many of the speakers already mentioned out. Based on our calculation, so with the more and more competitive from renewable energy development, hybrid system with solar and energy storage getting more competitive if compared to the diesel generator. Here, just to show you some of the diagram and pictures why we need to use the microgrid or hybrid system. So with battery system, the power output from solar energy or wind energy is more friendly and more smooth to the end user. So this is one beautiful picture, beautiful pictures. Everybody probably now where this picture from. It's in Maldives, the middle of the Indian Ocean. In Maldives, at this moment, we are working on 27 islands with 2 technical type. The project, the totally volume is about 4.7 megawatt PV, 4.1 megawatt battery energy storage system, and 6.1 megawatt diesel generator. The project location is in north of the Maldives. In fact, this project is a combination of the PV and energy storage with existing diesel generator. In the traditional way, just the diesel generator provides power to the end user. But with TrinaBESS involvement, we upgrade the traditional way to the renewable energy solution. So we provide a SCADA to manage the PV energy storage and the diesel generator system, coordinate the load, allocate and control the energy, and maintain the smallest output of the energy. So PV, in this project, PV plus energy storage is a new additional system and combined with the existing diesel generator to improve the quality of the power supply, safety and stability, reduce the fossil fuel using, and lower down the cost of electricity. Also improve the rate of the multipurpose utilization of energy by adjust renewable resource. So TrinaBESS, the scope in this project is from from the equipment side, we provide solar PV panel, energy storage, diesel generator, monitoring and SCADA, and even the upgrade of the diesel distribution grid. That means from the beginning for this project, we provide a solution design, components survey, and procurement, system integration and construction and commissioning. Based on our project schedules, all the equipment on the way to the Maldives, and all the project 27 islands project should be finished by the next March. In Maldives microgrid project, we completed use our own software control system and our own product like the TrinaMEG. Okay, this is just one of the TrinaBESS product. Provide grid support and provide community on and off grid. Here I would like to show some about technical type I mentioned before. In Maldives project, we provide type 1 technical solution is diesel generator, existing diesel generator, still is the to supply the male power. And the PV plus battery energy storage system working as a back function. If necessary, battery energy storage will take part in the frequency regulation. Technical type B is PV power and the battery energy storage take the male power supply roller, and the diesel generator will work as the backup function. At the moment, all the design and procurement and testing already finished in China. All the goods on the way to the island. Okay, this is one pictures to show the future and the currently the project, what the benefits from the money saving. Before upgrade the existing grid system, for example, it's 100 cents, but after upgrade with our solution, the power consumption cost decreased to 60%. This will bring the money saving to the local people living in the island. So besides the money saving to the local island, more than 2,000 families, bring them better electricity and a better life. Also expect to save 5,000 liters of diesel oil per year. So according to Maldives country strategy, should 30% electricity supply come from renewable energy to reduce the carbon dioxide. So in this project, is expected to reduce the emission of carbon dioxide 20.5 tons per year. Thanks to our strong supply chain, we could cooperate. We are trying best to reduce the cost of energy storage system. Now we can provide the whole system with this price to the market. This price still under high quality. We deeply understand lower price doesn't mean lower quality. Lower price doesn't mean lower safety. As one of the fighters in ESS and the energy microgrid market, cost reduction is one of key battle to fight. Till today, energy storage product still is very small. Why it's so small? Because it's too expensive to end user and to the people. So all the players in energy storage market have to fighting for the cost until we can bring the cheaper and afford the cost to the people in the world. By the way, I also would like to introduce TrinaBESS, some product. Till today, TrinaBESS already developed 3 series complete product in the market. We call it Trina Home. That means for residential market, Trina Commercial, and the Trina Mega. Okay, Trina Home, we have S and T series. S means single phase. T means 3 phases. So the power is from 3.7 kilowatt to 5.2 kilowatt until 9.8 kilowatt. And the capacity of the battery is from 3 kilowatt hour to 8 kilowatt hour. So this year, we shipped more than 2,000 to the market. All the battery is modularization, moldable block for easily installation and maintenance and shipment. This is our commercial product. 3 phases. The capacity of the battery is also modularization. It's a modular block for customers' easy installation and maintenance. Meanwhile, we also have provide Trina Mega product. That's the standard container product. The power rating from 500 to 2,000 kilowatt, and the battery capacity from 500 kilowatt hour to 2,000 kilowatt hour. At the moment, we are developing the latest Trina Mega, the battery capacity within 3 megawatt hour. All the products include the Maldives microgrid project. We provide remote control and monitoring system, cloud platform. You can monitor all the system in your laptop or computer. Also, if necessary, you can download from the a cloud platform to your cell phone to monitor your product and your system in app model. Okay, this is my presentation and just a brief introduction our case we are doing now. Due to the project is still ongoing, so any questions we can discuss in person or just contact my 3 colleagues. Okay, they have the much better English and technology background. Thank you.
Thank you, Frank. Thanks, Frank. We'll hold the questions to the end if there is any, and we'll just move straight on to Thompson, who's the Regional Director of Sungrow Power Supply, and he's going to talk about turnkey solutions in their case and case study of SSEP. Like Frank, Thompson has a long history in the industry, and we know him and his company very well in Australia also. So looking forward to hear what the guys are doing in this space. So just join me in welcoming Thompson to the stage.
Good afternoon, everyone. Actually, first I want to introduce about the joint venture between Sungrow and Samsung SDI. Actually, I'm working for the joint venture. It was established the year before last year, and we are in charge of the ESS business. Later in the milestone, I may give more introduction about the JV. So, actually, today's presentation are comprised of 4 parts. One is the PV plus storage microgrid application. The other is micro case study and Sungrow Samsung intro and case references. Why I talk a lot about the microgrid here, because it's in Philippines, I mean in the Southeast Asia, actually microgrid is the most applications here. But I don't want to actually lead you to a wrong understanding of us, because we already have a lot of like utility skills and a CNI for like other kind of applications of ESS, okay? So, yeah, actually, regarding to the microgrid, usually we're facing 3 kind of situations. One is, you know, like and the fringe of the grid, when electricity requirement is getting huge for life manufacturing and etc. And the grid is unstable at all. You cannot rely on it. Think about you have a factory. How can you bear like even 3 minutes to 5 minutes intermittency? It's kind of vital, right? You need the very, stable power. The second situation is problems come with DG such as high cost for fuel consumption, noise, and etc. The situation 3, which is actually beneficial, and I think it's a positive for the PV plus ESS players, because you can see the number here is 500 gigawatt of power from diesel generator provided electricity worldwide. That means actually there is a huge market for us to take. Okay, so but we don't actually replace the whole diesel. We just help the owner of the project, help the consumer to save their electricity bill. Diesel will still be the backup of the system, which I will actually give more introduction later. So, the background here, first unstable grid, an expensive tariff, high cost for fuel, and high cost for carbon tax. If you can meet 2 or 3 of this kind of situation, I believe that it's very necessary for you to have a PV plus ESS microgrid. Okay. So the PV generation cost today is lower than the DG, and PV plus ESS play a new role for grids such as saving TCO, more like stable power supply, improving power quality. Actually, I believe that I'm not so familiar with solar, because my last job background is also with the battery. At that time, I was playing with the EV's battery packs, which has more higher requirements actually. Right now, I'm in the ESS field, but I believe that right now, 6 cent USD per kilowatt hour is very approachable, right? For solar power, it's even less than that. But think about the ESS. Right now, I think the LCOE of ESS with our system can from 7 cent USD to 12. So even the PV plus ESS added together, the LCOE is still much lower than the DG. I believe the DG price should be from 25 cent USD to 35 cent USD, excluding the maintenance like OPEX. So on average, not all the power needs to go through the ESS. A lot of power may be generated by the PV directly. So on average, 6 and let's say maybe 12 and most together is 18 cents, but the pure power from PV is only 6 cents. So what's the average? Our experience tells us that if you are with a PV plus ESS plant generating the power, maybe the average cost of the power should be around from 10 cents to 12. So it's almost half or even lower or 1/3 compared to DG. So let's say, you can see that's actually a scheme of the whole system. For the first source of power, you can have wind turbo or solar, and you can have you will have the battery and bidirectional star inverter, or what we say PCS means power conversion system, and loads and maybe a grid there. So that's a scheme of the whole system. But you should have a genset there as a backup, as a last guarantee, right? And so actually, you can, like compare the very conventional DG, 100% DG power station with the new school like PV plus ESS and DG. Actually, if you want to enter fringe of grid, I'm sorry, it's not a comparison with DG, but at the fringe of the grid, if you want to build up the conventional, like transmission, actually high TCO and long time construction and pollution, if you use DG, of course, but if you are using renewable energy with ESS, especially solar, actually easy for installation and optional for centralized or distributed system, and a full use of green resource friendly to environment. Okay, so our functions on PV plus storage, you can have a lot of functions like energy shifting, peak shaving. Peak shaving is more for the industry and the commercial industry, I think, and improving grid quality, postpone transforming of the grid network, energy backup, and bill saving. Basically, they're divided into two kind of solutions. One is we call it AC bus bar. It's mostly for a large-scale microgrid in remote area without electricity. Later, I will share a reference with you, which is, phenomenal, and that is use the AC bus bar. And the features, actually the advantages is centralized management, high efficient flexibility, easy to integrate, and different renewable power sources, and avoid update of transmission network. But for a lot of other like microgrid, our references in Maldives and Cambodia, which is used the latter one is called DC bus bar. Okay, you can see there is sometimes a grid, sometimes not. You have the PV, you have DC-DC inverter, and the PCS, a battery, also the EMS for the whole system. So, okay. This is one of our projects in Cambodia. We call that Green Factory. So before we came there, it's into the fringe of the grid, so a lot of intermittency. Also, the power from the grid is very expensive, so owner of the factory choose to use the DG instead of the grid power. At least it doesn't, it's kind of stable compared to grid because it doesn't have to suffer a lot of intermittency anymore. But the thing is that the power from the DG is not that stable, like let's say the voltage or the frequency change a lot. So not high quality of the power. The other thing is it is very expensive. After we come there, right now they use 500 kilowatt PCS plus 2.7 megawatt hours battery, replace a big part of diesel. Right now, so their priority right now, let's say, this is the case study that's before. You can see they have this kind of problems. This is right now. Okay. Yeah, this is the features of more on the technical side. It's a DC coupled system, high efficiency, seamless switch. Because we use our product, it's called, one of our products is called ATS, automatic transferring switch. So from on-grid to off-grid mode, actually switching time is like less than 10 milliseconds. Okay, and a 1+1 backup system, more stable. So, so the priority you can see here is solar first, and then battery, then grid, DG as a last backup, and optimize the best, avoid loss of PV, stable renewable power supply, and grid as the backup, reduce rely on grid. But DG is less the like guarantee. Yeah. So maybe I do some introduction about my company. This is our testing center platform because we are authorized by TUV, UL, and CNUS. So actually a lot of new certifications. We can have the port testing ourselves and just get approved. For example, for Australians, AS4777.2, normally company, maybe I heard they will spend like 6 to 8 months to get a certification. But for us, we decided to go to the market. We only spend less than 3 months. So that's due to our testing center. Okay. This is the milestone of Sungrow Samsung SDI. You can see in 2006, Sungrow Group, we have the first starter inverter with on-grid, off-grid mode switch. And Samsung SDI in 2010 have the lithium-ion supplier globally. So both companies have focused on the ESS more than 10 years. So in 2015, we decided to have a joint venture. What I want to say more is that how do we define ourselves? We are actually an integrator of the ESS with all the key components developed and manufactured by ourselves, including the battery systems, the PCS, and the EMS, three most vital components. So I think we are very unique. You cannot find another company like us. I mean, there are a lot of integrators, sure. There are a lot of PCS players, suppliers, battery suppliers, but can you find another integrator with all the key components developed and manufactured by himself? I checked, the answer is no. So what's our priority or advantage with this kind of feature? I believe there are 3 aspects actually. In the pre-sales aspect, when we are doing the technical communication and discussion with our customers, we can supply their a turnkey solution, container or not containerized, it doesn't matter, but a turnkey solution. It's shorter, it much shorter a lot about the discussion, technical discussion and communication time, make customer more convenient and this process, okay? And as delivery time, because all the components are manufactured by ourselves, so it's more controllable on the quality as well as on the delivery time. What is more important is for the after-sales service, because we take 100% of the turnkey solution. So if there is anything wrong or failures with our systems, we are the one to fix it. We are the one to take responsibility. We don't have to talk to any like other suppliers, to make this kind of thing more complicated and make this the period of solving the problem much longer. So that's also 3 questions customer ask me most. Okay. So this is the picture of our factory. 2 main buildings with 2 gigawatt-hours lithium-ion battery capacity and 3 gigawatt-hour power converter, means PCS. Okay. And 3 gigawatt-hours, 6 gigawatt-hours of ESS integration capacity. This is the patents we already got. It's 850 patents of inverter and 8,000 patents of battery technology. So you can see, actually, the whole system is consisted of 3 key components I mentioned just now. EMS with the SCADA system, means energy management system, more on software side, and the lithium-ion battery system, and a storage inverter. So these 3 components are the key things in the system, and all done by ourselves. The next step after this production is the integration job. We offer our customer a turnkey solution of container. So this is some light specs of the battery racks. This is our product, a residential, which we're deploying Australian market. I believe next step probably Japan, because for residential, It is very important for after-sales service, right? So actually in Australia, we have a very strong team for that. And this is our like large scale of ESS. We have like different solutions according to the customer and technical requirement. We can actually integrate PCS with lithium-ion battery, and HVAC means heating, AC, air conditioning and ventilation system, and a firefighting system in one container. We can also offer you another solution that we need to integrate the PCS with transformer in one container, and we integrate the battery system in another container to maximum the capacity of the battery. And in our 40 feet container, due to the high density of Samsung SDI's battery, actually, if at a standard container, we can reach as high capacity as, I think, 4 megawatt hours plus. And if you use a HQ, more higher container, it can reach, it can be up to 6 megawatt hours. Okay, this is our certifications, some very, standard certifications. This is our after-sales service centers or subsidiaries. In my region, APAC, actually we have in Japan, Australia, Thailand. Also right now, I think we have an after-sales center in Philippines too. Okay. Case references. This is a number. I believe that some are, this result also counted in before joint venture was formed from both sides. So it's 400 plus projects and more than 1.3 plus gigawatt hour storage installations globally. So actually, I will spend a little time on this project because it's very significant for us. I can say that there are two modes for this project. Firstly, it is absolutely the world's largest microgrid. The second is it is of the highest altitude all over the world. ESS project. You can see the configuration is 13 megawatt peak PV and 7 megawatt PCS and 23.5 megawatt hours batteries. And it is a Chinese state governmental project. So actually in the bidding, there are a lot of competitions, but finally we win the bidder and supply the whole ESS. And the altitude is above 5,000 meters, so you can say that it's in Tibet, so not enough oxygen. So for the after-sales centers, actually we choose the engineer of the athlete quality of body to go there. Okay, so, and also the storage inverter is a VSG technology. It's called virtual simulation generating, because, you know, the PCS need to be compatible with the generator. When the DG generator, when it stops or it starts, actually it doesn't act at once. It will slow down, stop, or slow down, start, right? There is inertia. So this technology is that make the PCS to be compatible to simulate the generating, to do the seamless cooperation with the DG. So to provide more like stable quality of power when at the switching process. Okay, this is in South Sudan. The project is also microgrid. And this one is in Maldives, 5 islands. Actually, this year, I believe we won also the project of 26 islands in Maldives. Okay. This is other like case references in South Sudan and Sunshine and Great Britain. Yeah. And I believe that actually this year, because it's a fresh company established in the year before last year, and last year we go to the materialized process of operation. So this year is a big year for us. Actually, we have several projects delivered to USA, UK, and Australia, Japan. But you know, because we don't have pictures yet, it's new project. Some are in installation process, some are in delivery process. So maybe it's not in this presentation, but I can introduce to you is that in England this year we will have 11 megawatt hours. I'm sorry, 22. USA 11 megawatt hours, not totally just a single project. And in Australia we have like 1 megawatt hours of project of microgrid. We will have 5 of this kind of project. And also CNI. In Japan, we already have 3.3 megawatt hours delivery, and the next order will be 21 megawatt hours. So this is what we achieved this year. Okay, so thanks everybody. Yeah.
Thank you, Thompson. We'll just hold off on the questions, so you're off free for a few moments. Okay. So we jump straight on to the third section in this session, and it's Kushagra, who's the president and co-founder of SunSource Energy, who's going to give us his view on the solar PV micro utility model. Like the other guys, obviously extensive experience, but looking at the biography, the thing that caught my attention is you're a published author. So I don't think we've had one of them yet today. So just an interesting point that we see in Kushagra. So looking forward to hearing what you have to say, and then we'll have a few minutes for questions at the end.
Thank you. Yeah. Thank you. Oh. Yeah. So first of all, thanks everyone. I believe everyone had a coffee, and already good amount of detailed information is flowing in the sessions. So So at SunSource, we are focused on solar PV implementation, mostly focused on commercial industrial projects behind the meter, although we are quite active in the utility scale, but major focus is commercial industrial projects behind the meter. A lot of it has been with storage as well as integration with diesel as well. Later in the slides, I have picked up a project which we have implemented about 5 years ago. It's still running very well. I just wanted to share some data, which has eliminated almost diesel running almost. I think it is down, not eliminated, but down to almost like 5 to 10% on annual basis. Integrated with storage and solar. So we are a group of about 125 people spread across different regions, but home office or home bases in India. We also have a presence in Philippines, in Manila, in actually Ortigas and Davao. So we focus in different regions, different strategies. We act as an integrator and developer, and also bring third-party financing to the projects in India. But in Southeast Asia and other parts, we are developing projects and supporting other integrators. So we are not a manufacturer. We basically look at working in at the EPC and development space, and work with other investors. So main focus areas are CNI, megawatt scale, as well as some off-grid applications. CNI, we have implemented now close to more than 100 plus projects, different types, 100% solar plus diesel, plus storage, just purely solar and grid, multiple applications. So largest rooftop till date we have implemented single rooftop 2 megawatts. Now we implementing a 10 megawatt behind the meter project. So we understand a lot of frequency issues, capacitor bank issues, and other regulatory aspects of it. So a lot of technical challenges related to it. We actually have won Google's Global Impact Challenge award for one of our projects, which was implemented in one of the rural areas in India. On On the megawatts scale size, we have done some projects in Philippines as well, quite challenging on a mountainous terrain. I think we'll go into it detail later. We are one of the highest rated category partners with the Ministry of New and Renewable Energy in India. I think now we are the 5th largest CNI provider in India, with the top being with the Tata. So some of the clients which we have worked with are Coca-Cola. We have done with EPI here, we've done installations at Robinson's Mall. So different types. A lot of it is behind the meter. Again, some local projects here. This is interesting projects. It's on a rolling terrain. We haven't moved the dirt. We had just followed it was a very, very technically challenged remote location and time pressures. So very technically challenged project. This is on one of the malls here. It's again behind the meter, connected on a rooftop. This one we are implementing in Davao in Philippines. I think it's going to be one of the larger projects in that region. This is going to be integrated with their DG as well as with the grid. So, but we are looking at more with storage as well in that region. So coming to the case study which I picked up actually. So this is interesting, small project, but the reason I picked up this case study is it's now almost 5 years. So it can give a different perspective, because back then we didn't had that type of battery management system, that kind of evolved lithium-ion batteries. So we in fact went traditional in this particular project. We actually used lead acid battery. So it's a 100 kilowatt PV with a 300 kilowatt hour battery bank. We used 192 cells, and interesting thing in this particular project is it's a residential school with some day boarding and some night boarding over there. And the school was mostly running, almost actually 100% running on DG. And the client of ours was fed up with the DG, not because the cost was higher, but there was a theft of pilferage with the DG as well. So they were paying almost close to like 40 cents per unit. So they literally wanted to shut down the DG piece of it. So they tried solar, but it didn't work very well in the initial days. But then we came in and then designed the whole new system, came up with different monitoring aspect. And we have been now monitoring it very, very closely, our team. And we have trained the local maintenance guys. So they do a proper maintenance. We do remote maintenance of the project. Our guys goes there on a quarterly visit. And interestingly, what has been said about lithium, so lead acid battery, it turned out to be, we initially modeled to replace the lead acid batteries over 5 years. But now it turns out, to a surprise, only out of 192 cells, only 7 or 8 have gone bad over last 5 years. So which is very interesting. That's why I wanted to bring it here. We have divided the whole project into 4 different clusters. And we see, and we keep the maintenance high, and that too, 7 batteries came with a 5-year maintenance, 5-year warranty, and those 7 or 8 cells have also been replaced by the battery manufacturer. And since the clusters and the project is designed into 4 different clusters, the interesting piece of that is it is not impacting the overall coordination between each others. And we see first cluster will have to replace in another 1.5 years. The next cluster maybe in 2.5 years. So which is interesting, because when we modeled the project, we modeled with 5 years we'll replace the entire battery bank. Now we'll have to replace the first cluster in 6.5 years later, another cluster probably 7.5 years later. And so you can see how it has panned out. When this project was implemented, the cost was also high. So, but since the pilferage, including the diesel cost, was higher, so the recovery happened quite fast in this particular project. So plant capacity is 100 kilowatt. As I said, it's a 3-phase system, and took about quickly. At that time, it was more challenging. But now we have done larger projects, much more smoother, much more better returns, but it gives a different perspective, spread across. So we used at that time SMA topology, and with the local battery manufacturer So, system at a glance. Yeah, so it allows, allows integration between anywhere from 5 kilowatt to 300 kilowatt. So that 24-hour load is about 5 kilowatt over there. So we can actually go to 5 kilowatt, which is bare minimum, and then go up to 300 kilowatt, depending on how the functionality or the requirement is. And if what we have seen is across the year, if there are continuous, let's say about a week or 10 days of rain, and so literally the batteries are not getting charged, so we can integrate, the diesel turns on, but it has now gone to almost like 5 to 10%, which is quite a large amount of savings. And yeah. So just give a perspective on the Philippines microgrid. So we have been implementing a lot of learnings from that project. So we're implementing a lot of other projects of larger scale now. A couple of megawatts including with a couple of megawatt of battery storage. But we didn't have any data. So I think this is a good reference point. And it also, it is helping us when we are looking at newer battery technologies, including lithium ion. It helps us understand what actually will take, and how much is we can see now the cost savings coming from lead acid to lithium ion, although they're bulky as well. So this, I'm not sure, a lot of people may have already seen this map. This Philippines 7,000 island SPUG market is mostly is actually 100% focused on the Philippines, the island market. It's so SPUG rates are varying from anywhere from 5 to 6.5 pesos, but this is an older chart. But then there is an indirect subsidy which comes through from the federal government to the SPUG. So actually it pays up more. So there is an opportunity to develop the islands. So we have looked at a couple of them, but from a regulatory perspective, going through SPUG, getting all the electric co-ops approval, it's a time-consuming process. But we are seeing there is a tremendous amount of opportunity within this country. So we're quite committed. So as we all know, future market looks quite well. This is picked up from a particular research study. So we are getting getting to a inflection point where the market is really going to scale up. So we are locally here in Philippines. We are based in Singapore, New Delhi in India, and also in US. So we are quite flexible, different approaches we adopt, and technical in nature. Thank you.
Thank you, Kushagra. It's an indication of where the industry is going, that there's so many relevant case studies actually up and operational. So I think it answers a lot of the questions that we've discussed over the 2 days about whether it's commercially viable or not. So we'll throw it open if anybody has any quick question for any of the guys. No? Well, I just, instead of picking on one in particular, there was something, Thompson, you put up on one of your slides, and the three you guys can potentially answer it all together, because it's something that just baffles me a little bit. 850 separate patents that you guys have registered, for your system. I'm sure Trina probably something similar, and I'm sure Ugarda is probably something similar as well. So where do you see the whole risk around the whole patency IP part of the industry at the moment, in general, not just for your own projects, but there's so many technology providers at the moment all doing things very similarly. How relevant is the IP concerns to your separate companies? Frank doesn't want to talk to me.
I mean, the highest risk?
Mm.
Right now, actually, according to our operation experience and the technical design process, we don't see a lot of risk on the technical or operation side, but there is risk on the finance part. The thing is that if like for large utility, like utility scale of ESS, if you have a FIT or PPA with a national grid company, actually it's pretty easier for our customer to get the financing. But the thing is that if we say microgrid, we have like two kinds of modes of microgrid. One is we call that Maldives modes. It's financed by ADB. That one you don't have problem, but there are a lot of demands for like our Cambodian green factory style. That one is actually the owner is the owner of the factory, and the EPC is trying to do a BOT with him. So it's kind of the EPC will build up the PV plus ESS power station and keep generating power for a couple of months or 1 year like that, and sell the power, have a PPA sell the power to the owner of the factory. And after that, he will sell the whole project to the owner of the factory. But the thing is that how can we make this kind of case popular? We feel it is really hard because that kind of very private PPA, actually you cannot guide finance, right? So it's not credited enough. So that's a big part. So yeah, to make this kind of fringe, the fringe of grid, this kind of PV plus, yes, that's more popular. Yeah.
Thanks, Thompson. So if we've no last question for the guys, we'll move on to our last session. So thank you guys for showing your case studies. So our last session, we'll invite Herman from EY to come up, and you'll see in his portfolio and in his bio that he's an extensive experience in this space with such a long title. So I think he should be the fountain of all knowledge, perhaps, Herman. So if you'd like to take the stage and invite your panel to join you.
Thank you very much. For this last session, I would like to invite my expert panel, Mr. Steve, Mr. Rossellino, and Mr. Edmund Araga.